welcome to my session today. My name is Stefan Glienke. For those of you who keep saying my name wrong, when you get the slides, you can click there and it will exactly tell you how it's being spelled. Also, a small disclaimer, I'm not a Borg, I'm not a dictator, but I'm personality type ISTP, which might explain some things. If you have any questions later, either talk to me or send me an email. You can visit my blog, where I occasionally blog about. In recent past it was a bit more silent, but I have some things come up there. Well, since you see me in person and see how I look in real life, I thought I put that one here because that is usually how you see me online, because I'm using that avatar there. Some people say they might recognize me from that one in real life. I don't know. Today we will talk about, well, everyone probably has had that. The application is slow and you want to find out why. And we will talk about, first of all, why am I here and talking about this subject? What is my background with profiling and optimizing things, and maybe even your motivation. Why do you want to profile an application except that you found out something is not working as you want to be, or your customers want to be? We will talk about different kinds of profiling briefly, and then we will look at the little tool which is called Map to PDB and why we need it, and then we will go into looking more into Intel VTune Profiler. Small disclaimer, there won't be any commercial product placement in this presentation, except one tiny one about this book, because, well, that is probably something you want to look in either before profiling or after profiling, and even there's a small section about possible profilers, because the one I'm talking today is not the only possibility. And especially if you are one of the poor persons that don't have to work with an Intel CPU because they're using a MacBook or an AMD, you probably won't be able to use VTune because, well, that one is from Intel. And I've asked several people that were working with AMD CPUs, and they said, well, when I'm trying to use it, it will say, well, it doesn't support your CPU. On the other hand, I've seen other people say, well, you can use some basic features, but not everything that is specific to Intel CPU. So you might use, if you're using an AMD CPU, there's a product by AMD, which is called uProf. In comparison, it's not as cool as VTune, I think. Maybe they step up their game, but you can do similar things with it. We will see later what you can do with VTune. As I mentioned, a bit of background. Why am I a person that is profiling code? Apart from my, well, innate curiosity about how things work internally. If you attended Jim's session yesterday, where he showed the two kinds of code that you might write, I'm more of, I think it was the right side on his slide where it says the library code, because I'm mostly a runtime library developer, and that is usually the code that you want to squeeze every possible performance out of it. So, I mean, if you say using a list and you're iterating your items and you're doing your business logic with the items, you don't want to have time wasted just iterating your list and doing some list operations. Then, well, I'm not stopping there, and as Ian said, sometimes I can be quite obnoxious. So I went a bit further and tried to implement some performance improvement inside Delphi RTL. Again, if you get to the slides, you can click on that one and it will show you all the issues in the old Jira system, which is still up there. We call them internal the better series, because I named all the issues like better blah blah blah. And quite a few of those already have been integrated in the past few releases. So I'm naturally also profiling some code, and I'm finding some code that is inside the RTL, and look into that and say, oh, it can be optimized. And of course, everyone probably thought about that. Oh, there was this quote about premature optimization, and everyone knows just the first part. I mean, many people just know the first part, but it's from the book, and of course he goes on, and he says, well, there's this 97% of time where we don't want to optimize, but we don't want to pass on those critical 3%. And I'm oftentimes that 3% guy. So the motivation, well, obviously fixing slow code and or finding out what is actually slow in your application. Because if you followed not only Primož's suggestion to measure and not guess, and basically everyone that is talking about this subject will tell you, okay, well, you might have an idea what could be wrong, because I mean, you mostly know your code and what you wrote, but sometimes it can be quite surprising that it's not what you were thinking, but something else. And I mean, that might be some things.
Most.
And maybe you are even curious to learn about your application and, well, actually be curious about, well, where is it actually spending the resources I have on my PC? Learn a bit more, and then eventually take that knowledge and then apply it to your future coding. So there are various ways of profiling, but I just divide them into two big categories here. The first one being instrumentation. When you're using an instrumentation profiler, for example, AQTime, it changes the source code or the binary code. And most profilers, more profound profilers in that category actually change the binary code and not the source code. Although some instrument the source code, maybe create a copy of that and then compile that one and put their code in there. And it can be more accurate in terms of call counts. If you want to see how often some code is being called, some method is being called, that will be 100% accurate because every method has this counter inside of it. But of course, it has a varying amount of overhead because even the smallest method that you decide to instrument, most of the time you can say, okay, I want to instrument these parts and I don't want to instrument some other parts. So if code is very small, it might add a significant overhead to that code. And also, if code is inlined, that might be different, or you might not catch that code at all. And of course, the other one, and that is the one we are looking into today, is the so-called sampling profiling. What it is doing is interrupting the program at a regular basis. It's a bit like, sometimes you can even write your own sampling profiler, I mean, with a bit of knowledge, but it's basically as if you were stepping through the code in the IDE and hitting F5 many times and having every line with a breakpoint, or like stepping through. And then looking at the code and saying, okay, where am I at the current point? Of course, with a fixed interval, so like every microsecond or something. At first, it might look less accurate because you might have some very small pieces of code that are just being called in between those peaking intervals, and you might never see them. But if you think about, okay, what are we achieving in this context of this talk, looking at code that takes a significant amount of time. And if that code takes a significant amount of time, chances are very high that it shows up there. In that case, you're not interested in these very tiny pieces of code, and the chance that they always go right in between those intervals is very small. So the code that takes a lot of time will show up in your result. at least in my experience, I've never seen a result where I had some code not showing up and then I eventually find out, oh, that was not even there. Because, well, if it takes time, it will show up there. Although you might not see the exact call count, but it's just like sampling every microsecond, looking at the application and checking where it is. So I mentioned map to PDB. Well, who doesn't know what a map file is? Okay, fine. So what is a PDB file? It stands for Program Database or Program Debug Database. Some people are not agreeing if it's debug in there or not, but it certainly does not stand for Python debugger, which you might find if you're looking for PDB online. It's similar to a map file. It contains the information about your program, the methods, the addresses, the names of the method to map back from your binary, which just contains addresses, and the profiler will of course just see, okay, code is at this address and it executing this instruction and so on, and you want to know what is the name of the method. So before we had this conversion to PDB files, we could use VTune, but it would probably just show, okay, well, method 4658 df or something is taking a very long time. I mean, you could go back and then find out what address that is, but that would be cumbersome. And we want to see, right, the names of the method and even go into the source code and might even find out that that one innocent looking line might be the culprit of my problem. Well, many compilers are able to generate them. Some are not, but thankfully, someone from the community closed the gap. I think he's not here. At least I haven't noticed that Anders is here. Well, shout out to Anders. Thank you for making this tool. You can get it from Bitbucket. You can compile it. I think it uses the inline variable feature, so it probably will only compile with 11, 10.4, I think, and on. But you can use it on map files, even ancient map files, probably. I mean, I've tested it down to Delphi XE, which is old enough by now, I think.
Yeah, 2007 even works.
Yeah, okay.
I used it at a big bank to improve their performance.
Okay. So, since originally it was to map to PDB, it takes a map file and produces a PDB file, and every application that you compile, you can tell how to generate a map file. But the thing why I was originally using it, because we have an application that is not just one executable, but an executable using runtime packages and using dynamically loaded DLLs. So most of the DLLs and some of the runtime packages we compile ourselves, so we could produce map files from them. But we are also using like RTL, BPL, and we don't have any map file for that. But thankfully, Embarcadero ships the JDBG file for it, and well, I pestered Anders so long until he gave up and decided to implement the support for also converting JDBG to PDB. So you can take the JDBG files that come with RUDStudio, then convert that one into a PDB, and then modify the, well, you have to modify the BPL. I mentioned that in the last piece here, to actually tell VTune to pick up the PDB file. Because VTune, I mean, VTune could just look if there's a PDB file, but eventually someone at Intel made that thought, well, no, it needs an additional piece inside the binary. In the binary header, there's some part where it has to have a flag that says, well, there's a certain debug information about this binary file, and then VTune is satisfied and it picks up the PDB file. So if you might have generated a PDB file and you're not seeing the correct name resolution in VTune, you might check if you call the map to PDB the correct way, which I will show in the next slide. So how to use it. You need to enable the debug information, your project options. Important, it's on the compiler page and not the linker page. The compiler page, there where you say debug information, I think this has simple debug information and full debug information or something like that, which is that option that makes the blue dots appear, if you notice. Or if you don't have that checked, you cannot place your breakpoints because, well, there are no debug informations. The one on the linker page is the one that says, well, put this TD32 debug information into the binary. But that's debug information that is not interesting to VTune. And then, of course, on the linker page, we have to enable the map file generation, usually in detailed mode. And then either in the command line, you have to call map pdb with the map file you generated, and then -bind, and then give it the binary file, well, executable DLL BPL. You can even integrate that into your IDE, either as a post-build option or via the tools menu. In the repo, in the README, it exactly explains how you can do that. So what is VTune? In my opinion, one of the most advanced performance analysis tools for x86. So sorry, ARM, from Intel, and of course it runs best on their own CPUs. As I said before, it might run on AMD, it might not. It certainly won't run, and I think in parallels on a MacBook. Probably there are other tools to do these kinds of profiling, I don't know, because I simply don't need them. However, it also runs on Linux, but also no experience with that. But it runs very fine on Windows, and as I mentioned before, it has a free license. You can use it for your commercial projects. Yes, Frank?
Can you run it in a VMware?
I have not tried it. I have seen some people mention that it had problems. I've seen some people say it works. It depends because, I mean, VTune came a long way, and even in the recent years there were heavy changes to the thing, so I cannot tell you how it would behave today. So far for the slides. Let's go to the VTune Profiler. So, I mean, I don't need to explain to you how you install that thing. It's straightforward. So if you start it up, it comes with a ton of documentation. Even when you start it, it has this little tour thingy where it shows, okay, here is how you get started, and then you can click here to do this first steps and so on. And it often has some explanations inside the tool itself that will further explain what things are doing here. So when you first, I'm using this slow code from Primo's book from our beloved Mr. Smith. Well, the first version, which is very, very slow code. However, I'm just showing you recorded examples here to not waste time with the profiling and stuff like that. But if you start it up, well, you can say what application you want to use. You can set some advanced properties here, which is not important right now. And then, which might be interesting later, you can, if you provide the PDB files, it's just showing information from that PDB file. So everything in your, let's say you just have that executable. So you have an executable and you have that PDB file, and of course it will profile and show everything that is in your code because that is in your PDB file. However, sometimes you might call into some Win APIs or some additional DLLs, and if you run a Delphi executable, it loads a lot of Windows DLLs. So even there might be some problem. And that is explained in documentation as well. In the binaries, you can add some location where it has to check and thankfully, Microsoft has these symbol servers where it downloads all the PDB files and it needs to, and you can specify, put that into a local folder, so not every time you're running the same application, it's downloading the same PDB files, it's storing it once, and then it looks it up. And which is quite a nice thing. I mean, you're not only seeing the method names, if you click on them, you're actually going into the code, granted, if you have, of course, specified where to find this code here. So you here can add all your source code directories and so on. Then when you start, you either have the possibility directly start, and then it starts the application and starts the profiling, but sometimes it's just, okay, I need to click here and there, and then eventually fill some form, and then I want to click that convert button, then it gets slow. So you probably just want to profile that part starting at the hit of the button. So you can start it in paused mode, it starts the profile application, but does not start the profiling. And then you later can unpause and it starts the profiling, you can even pause again. However, the pausing again, sometimes, at least for me, had a bit of a hiccup, and I usually just kill it and then it collects all the sample data, because I mean, I don't need the unprofile going on of the application, but just the deferred start. Pretty much.
But they don't have an API to do that from code.
They do, however, guess what?
Delphi.
Not for Delphi. It's some C++ code and some, I mean, I'm just basic knowledge of C++. Maybe someone with more C++ knowledge can say, oh, well, you can integrate that into your Delphi application. There is some API. I don't know how it works, but it is somehow there. Maybe someone can write something to, yeah.
This pause and unpause problem is not limited to VTune. Similar problems you have with EduTime and other profilers. It's probably somewhere deep in Windows where you try to do the process hacking. Yeah.
Can you also attach it to a running process?
I think I have not tried attaching it to a running process already. I usually start it from here and then unpause. I think I tried it once and it didn't work probably, but that was quite a quirky application anyway, so I don't know, it might work, yeah. So, if you start here, you have, I mean, we did not even start profiling. If you start, it usually suggests, okay, please, in a remote desktop on my working machine at the company. It suggests, okay, start with a performance snapshot if you have no idea what is actually causing this. I mean, if you have an idea or you know exactly because you looked at some, I mean, at your task manager and it's not the CPU going up, but some file access or something, you might look into different. But usually a performance snapshot is a good way to get started, and it gathers some basic information and it tells you what is going wrong. Let's see, I think I had this performance snapshot here of the slow code thing. Who remembers that slow code program for Primash book except Primash? Primash, do you remember what it was doing?
Yes. Maybe you can show it.
Yeah, it was generating prime numbers in a very naive way, let's say. A naive and unperformant way. It gives you some basic information, and I mean, you see here the top hotspots it said. It said how long it takes. I mean, that just ran for 7 seconds and the CPU time was like 5 seconds, which is not a great big deal, but the thing is, I was only like printing a few prime numbers. But apparently this one function took all the time. It says 97.6% of the time. And this is something that might be misleading first, and this is where you have to know your application. It always shows the effective CPU utilization histogram. And since I have a CPU with 20 virtual cores, or threads, it will always say, okay, using all of this 20 is ideal. Everything else is like okay or poor. I mean, even using 40 of them will be considered poor. So, I mean, you have to decide if you make explicitly say, okay, I'm running this on 4 cores or something, and it's showing you that it's running on 4 cores, that will be fine because you didn't say run on more, even if it say, well, it is poor. So obviously, every single-threaded application will be categorized as poor utilization of your CPU. So you have to keep that in mind and not say, oh, why is it red?
They always want you to make as many.
Yeah, of course, they want to use the entire CPU, of course. And then you have a few tabs here, which are different categories with different ways to look at the code. There's the bottom-up one, where it lists, depending on the ordering. Well, usually, in this case, it takes some CPU time because I'm focused on, okay, it's spending CPU time for calculating something. And you can drill down here and see where these method calls come from, because sometimes it will collect this one method. It might be called from different places, and maybe many places calling this method will be okay, but because it's feeding some data that is fine, and then there's this one call that is feeding like a ton of data, or maybe some data combination that might cause this performance problem, and you can see where it exactly comes from, and even what it is, how much time it is spending here. Then you have the call or callee one, which is another way to sort this, and you see here it says func_add and then address, which is from the NT DLL, and because I did not specify to use all the Microsoft PDB files, it just lists the address here, but for this program, it doesn't matter to look into all the Windows stuff that is happening, because the slow stuff is happening in our executable. Same with the top-down tree, which is yet another way to organize things. And the interesting thing is, I think they added that in last year or the year before, is the so-called flame graph, which might not be impressive in this simple application, but we will see another result. It is basically like a visualized call stack, and I'm myself more of a visual person, and it helps me understand the relations with function, especially as you can see here. There's this element in data divides called from 2 different places. One time from that slow method, and then again from that filter thing. And you can even, I mean, will make more sense in another application when there's more going on. You can go in there, and then it will drill down, and you can exactly see where things might be happening. Because sometimes a method itself might show up here with a very large bar, but it's calling other method, and the time being spent in that method alone is not the problem. The problem is that that method might make some calls in a repeated manner, and it could maybe use the result. The classic is like you have a getter of a property, and that getter is for some reason quite expensive. But of course you're using like my thingy dot property dot something, then in the loop my thingy dot property something, and then you're calling that property over and over and over, although it's returning the same thing. And so the method itself is not spending time, but it's spending times in the other method that it might call, and that you can see there. Again, we will see that in another example because it will show better there. Primož.
Maybe we will cover this later, but VTune only goes down to the method granularity? Or
Yeah, Primož asked if VTune only goes down to the method granularity. No.
Okay.
You can dive even deeper.
Okay.
And in fact, someone asked me before, okay, why do I want to do this? I don't want to mess with all the stuff I've seen you do, like going into the tiny details of, oh, there's one instruction too many, and you could do this assembler code different. That is not typically what you want to do in the first step, because, I mean, to fix that slow code, you don't need to dabble with.
There.
Of course, yeah. That is why we have our source.
Typical example. You have one method which takes
Yeah, wait for it. Wait for
I
it.
have said you will probably come it.
Another very interesting thing is down here, and I think all the tabs have it down here, and they will show all the threads and the utilization of each thread and the CPU for it. For example, this thread, you see it is busy doing things, not particularly useful things, but it's doing things. And if I had more threads and I could see if they are actually using CPUs in parallel, or if you have that typical problem that you have like multiple threads, but you always have like one thread doing work while the others are idle, and then another thread is doing things, and that might be a problem. And you can even see when there is a spin and overhead time because you're using some synchronization primitives that are not well behaving, or you are not utilizing the CPU at all. Well, you have that in another extra tab, just this one. Yes?
Can you also show or see whether things are recursive?
The question is if you can also see where things are recursive. I think, yeah, if you drill down with the call graph and you will eventually come back to the same method that you are already drilling down, you will see that there is some recursivity, yes. So the nice thing about this one is I could select some part here, and then I can say filter in by selection or filter out by selection. So even if you're profiling that thing and you probably pinpoint down some issue and want to get rid of all this noise left and right, and maybe there's some UI stuff happening before or after, and you want to get rid of that, you can, by time line, you can filter in or out, which are just doing here. It's updating the things, and it's just showing what is in that time frame. Down here in the footer, you have the different possibilities to actually filter more. You can, filter, it's showing how much CPU time it is using here. You can filter by different processes if you have many processes being profiled, which you can do. I did not do yet. I'm just always profiling just one process, but you can say, okay, I have these threads that are not relevant to my diagnose. You can say, okay, I want to just filter in. If you have other modules, like you have that DLL, you know that is not the issue. You can filter it out or in, and in any other filtering things. You can even say here. If you go back to let's use this one here. If you for some reason found out that, it's not, is it here? No. Oh, it disappeared because I was filtering, okay. Of course. Before we had the two calls there. I can say here again, I can right click and then I can say, okay, filter just this one. So if there are other calls happening, I'm not interested in those. Or you can do the reverse thing. So you can go really close to the data and filter everything out. It is just noise for your observation here. So to show that I was not lying about that coach, actually looking into the code, I go here and I see our lovely element in data divides and what it does. Sometimes these numbers here might not add up to 100% because I don't know what. Sometimes it's just a bit inaccurate, but in our case, it almost adds up to 100%. The relative time and the overall time here, and I can. So now I'm at the method level, and if you have more complex code, it will probably show more that there's a particular piece that might be slow. But in our case, I mean, we're just doing a loop and modular operation, and that is taking most of the time. Well, and probably the iteration. I said something about list and iteration earlier. I mean, might be even that code is like calling the enumerator on the list a bit for a bit overhead, but that is where all the time is being spent.
Calling get next.
Yeah. Although that might be inline, I'm not. I think I was not compiling that one in the latest one because that one might look a bit different. I think I compiled it in 10.1 or something, which had not the inlining of the get next, move next, and get current in the iterator. Although the list iterator still has a tiny bit of overhead, but it's just me nitpicking on things. And if you really want to go fancy, you can, of course, also show the assembly code and then nerd out about, oh, there could be more optimization and this and that. Oh yeah, I know people that do that all the time. Yeah, myself included. So you can see here, I mean, this is an interesting thing as well. It shows the 48-something% here on the test instruction. Test is basically, well, do some check on this register and then do a conditional jump. And it shows that number here. And this is something, if you want to really deep dive into looking into assembler code, you always have to remember it's always the instruction before that one that might be the cause. Because that one is taking longer and deferring the execution of the next one, which might depend on what the previous one was calculating. And it was probably some people know, division is like the most costly operations that you can do, apart from accessing memory, in bad ways. And so, of course, it's not the test, but it's the division, and that the tests have to wait until the result of the division is being done. So that is something that often pops up when you do sampling profile and go really low level. Sometimes it's the instruction before that one that seems to be very costly. So just let's look at another one. We were dealing with like gigabytes of logs from a customer. And since I did not have some profiling information and I cannot run VTune at the customer side and stuff like that, well, wait, oh, that one. I was implementing a simple smart inspect log reader to look for certain patterns in the log because I know always like this pattern and then at some point there's a log line and I can calculate the time between these two log lines and then I get poor man's profiling data. So I did a simple command line executable that was just reading all the gigs of data, processing it, and then printing out the result. And of course, I was using TFileStream to read these files, and it was really slow. And these 44 seconds it took, it was not for like those 12 gigabytes I got, it was for like 1 point something gigabytes. I was like, what's going on here? Yeah, pretty much. You're right on spot. TFileStream. I have to say, how I was reading this file. So a smart inspect log file is like a block-based file that says, okay, here's the byte that says what is following next, and so you have dynamically sized blocks of different logging message because you have like, okay, enter method something, and then you can log your object, similar to like code side. And it's putting all these information in the log file. So I was just reading different size blocks. And of course I was always like read something or read string or like peek or go further in the file. And well, it turns out read file with like very tiny accesses directly to the file is not what is, I mean, I wasn't surprised to see that, but I was reminded, oh, just using TFileStream in that pattern is probably not the good way to do. So, what was the solution? Pretty much, you know?
Yeah, I know.
Tell me.
We can see it.
Yeah, exactly. Using TBufferedFileStream because that one is always reading in chunks and then serving the chunks from memory. And that one, I mean, you can see it was the same amount of data. It was done in 2 point.
Or if you are on Delphi before TBufferedFileStream, you can go to my GitHub. There is buffered file unit, or it's called GP huge file unit, which supports buffered access.
Yeah. So if you have a Delphi
you can
version
use it in Delphi 7.
that has not buffered FileStream, pretty much has you covered. So that was another. I mean, and funnily enough, if you look at this one, I mean, it's spending quite amount of CPU time here. It's not like, okay, this is some I/O going on, but actually something is happening there that makes the CPU run crazy. Although it might be some delayed I/O operation or something, but it's showing up as wasted CPU time. So that one was also very simple in terms of drilling down the flame graph. Let's see this one here. Oh. One thing I really don't like is if you have different projects and you want to look at the results, it always can only open like one project and it closes the other one, but yeah. But can run multiple instances to just look at the results if you want. So this one is just running the Spring 4D unit tests and then running the profiler with it. I mean, it's just unit tests and it runs some stuff more often and some stuff less often, and especially it has quite some heavy stress test on some sorting algorithm because we implemented a stable sorting algorithm called TimSort, and it's quite convoluted algorithm, not a simple one as other sorting algorithms, and so we did does a lot of tests. So that is why it's showing the compare int function here as one of the top things. On the other hand, it shows string assignment as one of the top elements. And my favorite RTL functions, move and fill char. I would have to look into that one because I don't remember which version I compiled it with. But depending on the Delphi version, you might compile it with, the results might look a bit different. However, let's look at this one. Again, we can go into this one. We can see here, use source. And yeah, I went ahead of myself here and implemented it actually in assembler. Because I figured, well, for sorting, I mean, chances are like 50-50, well, like if you have different elements, like numbers from 1 to n and the number just 1, so you always have like either it's bigger or it's smaller, and it's a 50-50 chance. And as you might know, well, CPUs like to do this thing like speculative execution. They get ahead of themselves, and then eventually if they find out they took the wrong path, they have to go back and go the other way. If they choose the right path, they are incredibly fast, and this is why our modern hardware or CPUs are so incredibly fast. Not because the instructions are so fast, not only that, but because they are just, like if you're going on the train and there's a tracks, what's the English name again for the splitting? Fork? Junction, thank you. So you have a junction and you have the train going through, and it's on the right track, the train can go ahead and doesn't have to stop. Well, however, if the train wants to go to the other side, it has to stop, the person has turn the junction, and then it has to start again, and then you can go up to speed again. So that is how, basically, in layman's words, how the CPUs work. So the classic code you have for an execution is, well, if this one is smaller, then return -1, and if the other one is smaller, then return 1, and if they're equal, then return 0. And what the Delphi compiler does here is like branching. And I didn't like that, especially for sorting. And there's this other way where you can use other instruction, and so this code is here written in assembler, different from how you typically do it in the classic way. Just to squeeze out these few microseconds more. But as you can see here, we have assembly code inside our Delphi source code, and you can still see like the different timings it is taking here. Although sometimes they might not be 100% sure. And again, I think what we see here is again like the time, because that line actually doesn't take any time because that has not instruction in there. That ASM is just like a begin of the method. So again, it might be the instruction before calling into that method that took some time, and then eventually it arrived here, and then it says, okay, well, it took some time until I was here. So that's just that. Let's look into that other one. Oh, we can look actually into these. Yes?
What was the solution
For
improve that to make this function inline or
Oh no, there was no. It's just an example of a more complex code and what might pop up as top things. That's already optimized code. I was just running all the Spring tests through the sampling profiler to produce some more data to show here.
But you didn't have to test it. If
Yeah.
inline you would solve that.
Yeah, unfortunately we cannot inline assembly code.
Oh.
So, and especially if you're using generics, you cannot inline like these comparers because they are behind an interface, and so you have to decouple them. You could make some inline version, but then you have to compile for every different type you want to sort. It will generate a lot of code, and then you have that other problem of code bloat due to generics. Yeah. So yeah, see, it's already the improved version of the move, I think. Yeah. That's, because that is using the AVX instructions here. That was some improvement to the system move method that I did some while ago. Utilizes SSE2 and AVX if you have a CPU that's supporting AVX. And nowadays, since Delphi only runs on operating systems that require SSE2 anyway, I said, well, why not use SSE in our runtime code, because, well, otherwise Delphi itself would not run anyway. So nowadays you can just assume that your CPU supports SSE2, which is, I mean, how now old. So the flame graph in this one would look quite more complex. Again, the base is the same. We're starting the test. It's running through D-unit, blah, blah, blah. And then we can see we had some test method. There was this unit test, say, array test, and we test some sort of stable sorting of some interfaces here. And you can then see how the time is being spent in the different methods. So we have here this array stable sort, and we were just sorting some functions that return integer. It doesn't make any sense, but just for a unit test's sake, so the function was returning the value that is being sorted by. Frank?
Can you have the possibility to compare this graph and improve it and get the same results to compare if your improvement works?
Maybe. I haven't. Interesting question. Frank asked if you can compare the graphs of like before an optimization and after an optimization and see the differences. I think I have seen some comparison of flame graphs, but I think it was not in the context of VTune. But I've also seen some ways to compare like different results of the functions. But I cannot tell you for sure if it was in VTune or if I have seen it somewhere else.
But you can do it worse with your improvement.
Of course, I mean, yeah. You cannot visually compare them, but I would look at the numbers and then see, well, how long did it take overall, given the same circumstances, of course. I mean, you have to take care if there's nothing else running on your machine that might interfere, but that is important all the time when you're measuring like differences, so you have not running your, I don't know. I mean, I had situations where I was coding along and then running some benchmarks, and then in my browser was watching some Netflix or something, and then I noticed that, something is going on here. And the funny thing is, when I was watching the stream, the code ran faster than I was not watching the stream. I don't know what happened.
I know this.
Yeah.
It's because the CPU on laptop especially, the CPU is always in use by the stream, and so it doesn't go down CPU speed, and so your code is running faster.
Yeah, that was my expectation.
Yeah.
And we have this where we should force the CPU to be in active mode instead of being.
Yeah, CPUs run in different modes, like in more like in the power consumption, in the power preserving mode, and then they go up to like super performance mode, and then they run faster. And sometimes that is why you might run multiple runs, not just one, because the CPU might be cold, it's called. So it might be run slower, or actually something else is running, and you might switch some things on and off on your CPU to avoid it. And especially, and I love and hate them, 12 and 13 generation Intel CPUs, because they have these efficiency cores. And sometimes, well, for whatever reason, your code runs on the one category, and sometimes it runs on the other one. And of course, efficiency cores, they are not as...
Affinity.
And especially if your program is a simple project as computing prime number, is no multi-threading, no visual interface, and so it will have big effect.
Another question?
Yeah, well, one of the things I was using Intel MAP kernel library, which actually ships VTunes with it. It's within the one API. And I have noticed, because I was trying to write like an internal general matrix multiplication without having to rely on MKL. And I found that at some points in some CPUs, there's some cache invalidation happens, which actually slows my code and runs faster on certain CPUs. So I couldn't figure out how can I profile the cache invalidation, because apparently from a CPU to a CPU, you need to make sure that what kind of, how to fit your cache, or like how to fit like a vector within the cache in the correct size of the cache, of the CPU cache, in a way that can fit most of the CPUs, but I was also struggling on how to profile this. I was not using VTunes. I'm trying to write my own profiler. But I'm interested to see if there is any way to profile the cache invalidations, because this is where I was struggling with the implementing SIMD code for multiplication.
So the question was if I can profile the cache invalidation, which might differ between different CPUs. I have to say I have no idea. You got me there. Probably since different CPUs, and even, I mean, that one, the hybrid CPUs have different cache sizes, depending on if you're running on E-core or on P-core, and different CPUs have different cache sizes for different caches. Probably have to fetch first like some information of the cache size and then adapt your algorithm if you really want to go that way. But without knowing exactly the algorithm, I don't know. I mean, even I have just the tip of the iceberg what this tool can do and go into all different kind of metrics. And I mean, if you go to this thing here, I mean, you notice I have this scroll bar here because I mean all the scary numbers. No, not here. Oh, it might be because that's just a hotspot thing. Let's see. I mean, we had just okay. How much time does it take with the CPU thingy here? No, it's just a hotspot thing that's not collecting there. Let's see if I have a result of. Because it gives you all kinds of different information about, okay, how many retire instructions do I have here? What's the latest latency of those instructions? All these low-level information about the different CPU. I think I always did the hotspots thing to get the broad overview. If you do the microarchitecture exploration, it really shows all kinds of information about, okay, this one is more, I mean, you can see it here like a bit. Oh, this one.
Can I add to this? Just check something because I was not sure. But yes, VTune allows you to profile low-level CPU performance counters. And most modern Intel CPUs will tell you how many cache hits versus misses were there.
Yeah.
Not cache invalidation, I don't think so, but at least you can see how good you are at hitting the cache.
It's probably defined that in the microarchitecture usage. Here it's just giving a broad overview, but you have like different things, and there I have a question mark, and you can then read more about it, and some of them tell you, okay, if the value here is high, it might indicate this or that problem, and yeah, probably if you have like page faults or something, there's probably an indication of, oh, there's some cache invalidation obviously happened before and I have to fetch that memory page again, yeah. So we just have 5 more minutes, but we are, I mean, right into Q&A already because I've showed everything I wanted to show you. So just keep questions coming.
Did you use other parts of VTune analysis personally?
Yeah, I mean, I typically start with the hotspots thing, then I go into the microarchitecture exploration, and for something I was using the threading thing here because it was really some nasty problem where there was some interference of some synchronization primitives fighting each other, and then I had some weird behavior there. And also, I mean, I was using this multi-read exclusive write synchronizer, which are called MRU.
The old one.
Yeah, the old one. Oh. Yeah. The old one, with a lot of overhead, and then eventually I found out, oh, that is fighting against the cache lines because the same things are in the same cache line, so it's always like sharing the cache line over the VRAM, and yeah, that one pointed out that issue. But I have not dabbled into the right bottom corner here, which is more about the GPU things. I think you were first.
Yes. I have a question about, can you store some templates? So let's say if you have an application and you want to exclude certain things, like you said, the filtering, or can you store that somehow so that you don't have to do it all over again each time you try to profile things?
So the question was if I can save those filters I did earlier into some kind of template. I have to say I have no idea, but it's a very good question.
First set up a filter.
Yeah, probably. And then, I mean, I would have noticed some save something. Just click there. No.
Maybe
But
you can save it as part of your project when you exit and you say yes.
Yeah, but then you cannot use it for like the next profile run and say, okay, I want to only like filter these methods or something. Yeah, it might work somewhere, but as I said, it comes with a ton of documentation, and I have to admit, I'm more like the hands-on guy, and then I only consult documentation when something is not working. So, you had a question, I think.
Yeah, but it was about another thing, not about the tool itself. So if you would like to keep asking about the tool, I will rather ask you later.
Okay.
About the multi-reader experience.
Okay. Just one remark, because someone said back in the day it came with this one API suite that Intel ships, but nowadays it's just a standalone installer, so you don't have to install all that other stuff that might not be interesting to you when you just want to use this one. Which is, I mean, convenient. Before you had like, and sign up something, even if it was a free version and so on and so forth, and now I can just download it and be gone. So, I think just want to show the last slide, which is add.
I have one more question.
Yeah.
What are the main obstacles you have run into with using VTune?
Oh, the main obstacles. I think the main obstacles was when I was running it on my own, on my old laptop. It just blue screened. That was the biggest obstacle. Then the next big obstacle was not having PDB files. Apart from that, it's just, I mean, getting used to how to interpret data and how to set it up and then find the right place where actually things happen. And I mean, I can tell from practice, and I mean, I know Vincent can tell you some stories about how it helped him to improve his product, find out where he was actually wasting CPU time and how to improve that. And I found some rather hard to find issues that could not pinpoint otherwise without actually running the code and then looking at, okay, where's the time being spent? Frank.
If you have one executable and one DLL, you told us you need both the map file converted for both, and can you combine these two files and get the performance from your main application and also from your DLL?
So Frank asked if you can combine PDB files from multiple binaries into one. I don't think so. I think for every binary you want some information from, you should provide the PDB file. You don't have to, as I showed earlier, if you know that something DLL doesn't do anything relevant to your investigation, you don't have to provide the PDB. And actually, I suggest not putting PDB files for everything, because then when VTune collected the data and it is running through all the PDB files and you give it PDB files for everything, it can take like forever. Some snarky side note at Intel, guys, profile VTune with VTune to improve that.
Maybe they already do.
Maybe. I mean, some things got better over time and some things got worse. So that's also for worse sometimes. So, thank you.
Thank you.